Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Geometrical, cis-trans, isomerism in cycloalkanes arises when two or more ring carbons each bear two different substituents, restricting rotation and creating non-superimposable spatial arrangements. Step 1. Identify the compound. The structure shown is 1,4-dimethylcyclohexane, a cyclohexane ring with one methyl group at C1 and one methyl group at C4. Step 2. Check the condition for geometrical isomerism. Each substituted ring carbon, C1 and C4, bears one CH3 group and one H atom, so both carbons carry two different groups. This satisfies the requirement for cis-trans isomerism in cyclic systems. Step 3. Enumerate the geometrical isomers. Cis 1,4-dimethylcyclohexane, both methyl groups on the same face of the ring, both up or both down. Trans 1,4-dimethylcyclohexane, methyl groups on opposite faces of the ring, one up, one down. Step 4. Check for additional isomers. Because the two substituted positions, C1 and C4, are related by a plane of symmetry in the ring, there are no additional diastereomers beyond cis and trans. No enantiomers need separate counting here because the question asks for geometrical isomers, cis and trans forms, giving exactly 2. Step 5. Evaluate wrong options. A. 0. Incorrect. Cis-trans isomerism clearly exists. C. 3. Incorrect. There is no third geometrical isomer for 1,4 disubstitution. D. 4. Incorrect. Overcounts. Only two distinct geometric isomers exist. Therefore, the correct answer is B. Therefore, the correct answer is option B.